this is primarily for industrial usage, but what is your vision like? As in, if you look at maybe 10, 15 years from now, will you be able to build something which can be used by general population? Can we use these small reactors at home? Hello, and welcome to another episode of Interviews with Experts. I'm Sumit, and today we are unpacking the future of clean energy, the rise of advanced microreactors, and the fragile global supply chains shaping these cutting edge innovations. Today, joining us is Alessandro Petruzzi, the co founder and CEO of Terra Innovatum. Alessandro has an incredible track record from his extensive academic research and managing international safety projects for nuclear facilities and serving as chair for OECD NEA expert group on reactor core thermal hydraulics. Today, he is here to talk about how Terra Innovatum is pushing the boundaries of nuclear tech. Alessandro, it is an absolute pleasure to have you with us. Welcome to the show.
My pleasure, and thank you for the invitation.
So let's dive right in. Alessandro, you have had quite a journey, from academia and global nuclear safety to founding Terra Innovatum. What was that light bulb moment that made you say, I need to build this myself?
Definitely the passion in respect to the nuclear technology and how this technology can really be supportive of development and the wellness of all world population. Personally, as any nuclear engineer, we think that nuclear is the right way to take for the technological development, for the growing of the human kind wellness, and that's the only way to keep the world also clean. We have more than 400 nuclear power plants operating for 60 years.
Okay.
We have the low fatality in our industry, and we know very well how to do with also the commissioning of the reactor, what is called the nuclear waste, notwithstanding I know that there is a lot of contradictory information. So in 2018, when we started, we had the idea to let the nuclear technology penetrate into the market, and in particular into this. At the beginning, 2018, the idea was to penetrate in the small size market. And when I say small size market, I refer to those kind of industry characterized by a very low demand, something up to 10 megawatt. Those industry are so small that they don't obviously cannot take power from large nuclear power plant. So the idea was to develop a micro nuclear reactor such to provide them with the right size of power in the way that not only the large utility or the large industry can benefit of the nuclear, but directly also the small industry with a behind the meter application, with an application that is basically safe by physics, that cannot melt, that cannot explode, and that can arrive and deployable everywhere. Everywhere you have a road, you can bring a reactor and you can set up in a very short time. So this was our vision on how to characterize the development of this century.
Right. Understood. So Alessandro, looking at the current global energy landscape, what was the massive overlooked problem that the SOLO Micro-Modular Reactor was specifically born to solve?
Today, as you know, everybody is requesting for more power. So we need more power because we need AI. We need AI because it's a problem of national security and development. So we need more energy. That's true. Can we do that? Yes, I think we can do, because not only with microreactor, but with large nuclear power plant and with additional type of source of power, we can do that. What is very difficult, in my opinion, in the next year will be how we will transmit the power we generated, the more power we generated to the final user. So I'm talking about the problem of the grid. So we are like now in the situation where everybody is saying, I want to have 3 cars by myself. So we need to triple the number of cars, but still we have the same highway. So this is the problem we are facing. JP Morgan estimated in about 21 trillion the cost for rebuilding and extend the capacity of the US grid. Is a large amount of money, but what is still more unknown is the time that will be needed. So I think SOLO what can do? SOLO is a behind the meter application, is a micro-reactor. So basically we don't need to be connected to the grid. We can, but we don't need. So basically you can bring this reactor everywhere, as I said before. You can get the reactor can operate for 15 years without refueling, and you have 1 megawatt electric continuously for 15 years. So that's an enormous advantage that gives stability of the cost of the electricity and allow any industrial owner to plan very well his future, because when you know your cost, and when you can predict very well your cost as owner, entrepreneur, you can plan much better what you need to do. So that's also the advantage to have SOLO.
Right. So Alessandro, let's talk hardware. You recently integrated a helium circulator into the SOLO test infrastructure. For our listeners who aren't nuclear engineers, why is this specific piece of tech such a game changer for your development timeline?
I'd say that is, I don't consider this really like a game changer. I consider it like a piece of the story that we are building. Actually, when we developed SOLO, our high-level requirements was to develop SOLO with material and components which were already developed and licensed. So this, with the idea that this can give us a speed up in the licensing and also in the supply chain. Helium blower for our primary circuit is part of the game we are playing together with many other components, which might be turbine, it might be the steam generator, it might be the graphite. So we are announcing day by day a step towards the completion of our reactor, because we think it's useful, because we want to give really tangibility of our project. Our project is not anymore on a paper. Our project is really in the execution phase, not only for licensing, but also on the supply chain. So anytime we are able to make an agreement with one of our suppliers, means that this part of the design has been completed, not only on the paper, but on the real fabrication line, and we are ready to get the component. And we will continue to do that up to the last component of the reactor is not finalized.
Okay. You partnered with Bold Rocky for this critical component. What made them the perfect fit, and how does this alliance actually help you sleep better at night when it comes to de-risking the technology?
Bold Rocky is very famous in this type of component. They have a very long-lasting experience in our supply chain. For each of our suppliers, we contact at least 2, but sometimes even 4 suppliers for the same component. So we consider all the suppliers we contacted very high qualified. We decided to go with Bold Rocky because it's very close to us, because they give a lot of confidence. But notwithstanding that, all the suppliers that we contacted again have a very high qualification. And the market of microreactor is something that will disrupt the nuclear supply chain, because large nuclear power plants are such that the supplier usually they were involved for a large activity once every 10 years, 15 years. So their business model was affected by this type of activity. When you move to the market of a microreactor where different units, several units per year has to be built, you pass to a different type of supply chain, to a different type of business model. So this is to say that in this business model, we need also more suppliers. Basically, what we are now doing is for the first of a kind that will be built in Illinois at the end of 2027. But the real game we are playing is the commercialization in 2028. And when we talk about commercialization for a large number of units, definitely we need several suppliers for the same components. So Boldrock is our best supplier in that sense for the FOC, but obviously we are looking towards several other suppliers, as it is for all our components, because again, the challenge is an enormous, and the number of components are really a lot when you talk about commercialization. So this is a key of the success. This will be a key of the success for the commercialization.
Right. Now, helium is essentially the lifeblood of next-gen microreactors like SOLO. What makes it so superior to other coolants, and what are the absolute toughest engineer hurdles to keeping these systems completely leak-proof?
Helium is a noble gas, with very nice property. In particular, is specific heat parameter is very good respect to the other, and this make from technical point of view better than other type of gas. Even though we may use other type of gas, there is a compromise between benefit and cost, efficiency and cost. Basically, we decide to go for helium because it seems to us superior, even though we have a version of our reactor that were developed from 2018 to today with a different type of gas. From the other side, helium is a very small atom and molecule. So as you say, the leakage of helium is quite, it was quite important in the past. How we decide to take care of that is basically with design such that the number of leakage, the linear leakage we have in our reactor is very limited. So we do a lot of welding, sealing, more than the welding, really sealing, and this will help to decrease the amount of helium that we will leak. And this should also go in together with the consideration that the amount of helium we have in our microreactor is very limited respect to previous type of reactor. So helium is not a concern, not only in terms of amount, but for us, for our technology, also in terms of the purity of helium, because you may have several, as everything, in nuclear we are used to use very sophisticated material component. In our reactor, we try to decrease this level of demand. Maybe we sacrifice a little the efficiency of the reactor, but also this is a compromise between cost and efficiency. Whenever the efficiency is coming, higher efficiency is coming with so large cost, we decide to stay at less efficient, but with less cost. So this was a compromise, and this was done also with helium. We don't need a very high purified helium, and this make also the supply chain quite friendly with us with that choice.
Okay. Alessandro, moving from the lab to the real world is really tough. How does this new testing infrastructure act as a catalyst to accelerate your commercialization?
I think the main idea here is the fact that we will build the reactor in a factory. So as you say, when you move from lab and from paper to real production, there is a lot of things that you need to change because it's very easy to design on a paper. Whenever you build and you do and you manufacture, obviously there is a lot of difficulties that you have to manage, and so you need to go back and improve your design and make your design suitable for the current technology by which you can build a reactor. But this is where our project and the project of Microreactor can really take a benefit. The fact that we build in a factory allows us to standardize the construction.
Okay.
So, and this is the way by which we can really take the challenge of the production and increase the number of units, because the standardization will help us to improve this kind of technology, how we produce the reactor, how we put all the elements inside the reactor, how we perforated, for instance, the graphite, or how we connect the different components each other. So what we are already doing is a series of procedures that we record and that we will improve day by day, year by year, because we needed to move from one reactor, the first of a kind, to tens, to hundreds, to thousands that we produce in 1 year. And this will be possible only trying to obviously improve this procedure and trying to go down with time of construction and cost of construction. And this is possible when you do in a factory. Obviously, if you produce in a site with a different team, with a different location, with a different challenge every time, will be very, very difficult. At the end, what we have in mind will be to arrive to a situation where our industry will be very similar to the car industry. So basically, you have to imagine a factory where all components generated by built in another factory will arrive, but in that factory we will assemble our reactor. So this is the model that we would like to do.
Understood. Now, Alessandro, looking ahead, what is the single biggest milestone Terra Innovatum needs to clear to take SOLO from a validated test to a deployment-ready reality?
Oh, the licensing is definitely the first step, because without license, you cannot build basically the reactor, okay?
Right.
So licensing is the big milestones, starting from June this year. So basically next week, we are starting our submission to US NRC. We have two tranches of submission, one between end of June and beginning of July, where we will submit half of the construction permit application and the other half will be submitted by the end of September. So this is a very near milestones for us. And there will be many others that will follow still in terms of licensing, but this is obviously the more near and more important for us. At the same time, the construction, 1 month ago, we announced to the market that we succeeded to perforate the graphite with the accuracy and the tolerance that we need for our project. And this was a very big success. We really see also our pieces of material and graphite that will build up our reactor. And this was, in some way, it was even more exciting than I have to see also the licensing. My team was doing licensing in different countries with different technologies. So we are used to that. But when we saw the construction of the first block of graphite built as we designed, this was a very exciting moment for us. We start to see that things are happening in the real world and not in the paper. So I would say that those are the two milestones: licensing, construction permit, and continue with that supply chain and the manufacturing of pieces that mock-up that will help us to start the real construction of the reactor beginning of next year.
Right. So let's talk about decarbonization. When you look at the global race towards decarbonization, where exactly does this micro-modular reactor plug into this massive puzzle?
This is an easy game for nuclear. Nuclear is, by definition, is the energy that is less CO2 impact. And I would say even more for microreactor, because when you see all the cycle, no? Because again, sometimes it is very difficult from technological point of view to account who is producing CO2 emissions, you know, because it's not what we sometimes we consider is only the last part, you know, the fact that there is industry that pollute the environment with emissions, but actually is the story is even much before, is when you start with mining, is when you start to say, okay, I have that power plant that produce electricity, but I needed to transmit the electricity, so I needed the copper for the grid. So story is really complex, is very difficult to do that. And also nuclear obviously has some CO2 impact because we are mining for uranium, we are doing concrete, so there is an impact, and this is part of to be an engineer. You know, as risk zero does not exist, CO2 emission zero does not exist in the real world, but exists the way by which you can minimize, and definitely nuclear is one of these, and micro even more, because again, micro is behind the meter, so the amount of additional material that we need is much less. And with us, basically, you can, again, produce for 15 years energy without additional refueling, and so less consumption and less emission for the mining or the fueling. And the impact on CO2 is really relevant. As you know, right now our main market is the United States, where the CO2 credit, tax credit is not very yet implemented, but this is very well implemented in Europe, where I'm now in Italy. There is a lot of the zone where I am. There is a lot of tissue paper, and starting from I think end of this year, they will need to have a balance of the CO2 in order to pay less taxes. So our solution will be very impacting in that regard.
Right. Alessandro, historically, heavy industry is one of the hardest sector to decarbonize. Do you see microreactors fundamentally rewriting how industrial hubs and decentralized grids get their power?
Definitely yes. Definitely yes. This is also the target that we had. We can bring to this industry directly electricity on the site without being connected to the grid, but we can also generate for them the heat and the temperature they may need. For the fog, we concentrate again on the execution, so our attention is to realize the reactor. So we cannot go very up with temperature as it is requested from some industrial process, but this is our choice now, just to get to the fog. But the possibility to increase the temperature and to arrive also to provide large industry not only with electricity, but in the case they need for the so-called process heat, we can also provide it. So far, anyway, SOLO is able to produce heat at about 900 Fahrenheit. So it's not it's about 500 C, a little less than 500 C. Some already of the industrial process heat you can do it, but definitely you can do also electricity, and this is very important because for instance, where I am in Europe, the large part, with the few exceptions that is coming from France, everything is not non-nuclear, and we may really see the advantage of in terms also of clean energy and also cost whenever you talk about for nuclear country and not. So our idea is to associate to those large industry our reactor as a sort of I don't like to say that because I don't like to be associated with batteries, but it's a sort of nuclear batteries, that whenever you say is 15 years of operation without touching the reactor itself, is really something that you put on close to the industry and then you leave to operate without even remembering. And this is possible. Let me add one aspect, because I know very well that nuclear, as I born in the time of Chernobyl, actually Chernobyl happens in 85, I was 10 years old. And this was the moment where, for some reason, I started to be passionate about nuclear, and I decided to do nuclear in the future. And this is what I did. And nuclear and the public opinion about nuclear is very important for the success.
Absolutely.
I had a lot of friends and parents that, depending on the years, were against my choice, and then now they are in favor, you know. How we build SOLO? We build SOLO, and why we are small power is because we want to be small power. Because small power means that basically we were able to disrupt the concept of nuclear melting and explosion from our design. Because a nuclear power plant, as you maybe know, whenever it is in shutdown condition, is not like other plants that produce zero power. They produce power. But in our case, as we are 5 megawatt thermal, 1 megawatt electric, the power that they generate is so low. And this power is so low that you cannot arrive to the melting temperature of any component and material inside the reactor. So you cannot melt. If you cannot melt, you don't produce hydrogen, you cannot explode. That's the reason why the reactor is small, and that's the reason why I'm saying that this reactor can really be close to an industry, can really be close to the even a dense populated area. I think you are familiar with the concept of research reactors. There are many research reactors worldwide. Research reactors are usually at university campus, where students are there every day, and you know they are there since 60 years, and even nobody's taking care of, oh, this is risky. No, it's not risky. So the concept that we are using is exactly this concept, and that's the reason why we built small power, and we say that this reactor can really be placed close to industry and even dense populated area.
Right, absolutely, yes. Now, let's talk about geopolitics, you know, pivoting to the macro picture, the bigger picture, you know, the highly volatile right now, you know, the world. How is the ongoing conflict in the Middle East actively rewriting the rules of global energy security and clean energy investment?
This is a tough question, because anytime we talk about energy asset is obviously geopolitical and is going even far from technical consideration. We think that the possibility to deploy micronuclear reactor everywhere is a sort of, let me say, democratization of energy or retail of energy. So definitely it's a geopolitical topic. Definitely we know that this is going to be impacting worldwide, because you know, if everybody can have access to electricity to reduce the cost, is something that is going to change the geopolitical worldwide. And so we know how our project is important. We know the extremely impact it may have on the social life, but also on political aspects, on industrial aspects, on the current economical even balance, because that's true that today the world is fully supported, the development of the world today is fully supported by oil and gas. That's clear that without oil and gas, we cannot do development. In some way, I think oil and gas will continue to stay because they play a fundamental role in our economics. But the idea of microreactor can really contribute to reduce the consumption, can really help to bring electricity in those countries where electricity today is not present, and can contribute, if we wish, to the stabilization of the geopolitical situation worldwide.
Right, understood. Alessandro, with the Strait of Hormuz acting as a geopolitical choke point, how vulnerable is the advanced nuclear supply chain to disruptions in critical inputs like helium?
Yes, it is because Qatar is one of the main supplier, but
Okay.
so far, at least for our reactor technology, as I said before, we don't need so large amount of helium,
Okay.
and we don't
Right.
need helium very purified. So in
Right.
that sense, I come back to my previous point.
Right.
And we have also to think that so far the situation of worldwide is also helium is very important not only for nuclear, it's very important also for chip, even maybe more important for AI than for nuclear technology itself. There is also a consideration. We need really to understand how much today the helium market is driven by demand or offer. This is also the other point. If we go back to maybe some years ago, 10 years ago, 20 years ago, the amount of helium that we need was really, really negligible. So I think as in all aspects, helium is not, let me say, it's not a rare material, okay? It is in some way. So I think there is the possibility with the future, with the increase of demand, to increase also the offer. Anyway, for our reactor, again, the amount of helium we have in each reactor is very limited. It's not pure. And again, we select helium because there is a choice for us. But this does not mean that in the future a reactor might be designed with, initially, I can tell you that in 2018 we start with CO2,
Okay.
with so this is also a possibility.
Right. Right. So next question, you have talked about this a bit. We are seeing an intense price shock in energy and petrochemicals, as you said. Paradoxically, does this geopolitical chaos actually make the economic argument for the decentralized resilient system like SOLO even stronger?
I think so. I think so. And in some way, I think also the model we have today, where we generate electricity in one place of the earth, yes, in one location, and we transmit, is a sort of technology that belongs to the last century, not to this century, that we heredited. There are several reasons why it is, in my opinion, much better to delocalize the production and to do it behind the meter. And in addition to economical consideration, the problem of the grids that I was mentioning before, and additional problem, things in a very, very congested city or in Europe, to build new grids. It'll be a mess. It'll be a terrible mess in a big city. In Italy, where I am, anytime you start to do something, you find something on the ground, and it is impossible. But in addition to all those topics, I think there is also a problem today of cybersecurity, because the fact that you have in the future things to have thousands of points where you generate a little of energy. This will be more resilient, more secure from cybersecurity attack, respect to a situation where you have a large production just localized in one point. So even it's not only question of energy distribution, which in my opinion will be more efficient, but is also an issue in terms of cybersecurity.
Right. Right. So, Alessandro, I understood that the tech you're working on, this is primarily for industrial usage. But what is your vision like? As in, if you look at maybe 10, 15 years from now, will you be able to build something which is which can be used by general population. Can we use these small reactors at home?
Okay, what I can envision in 15 years from now is a situation where there will be several solar units spread all over the countries in the world, used by small industry, municipality, hospital, even, why not, parking lots, hotels. Now, going to the point where each person can have a small nuclear power plant, I would say this is maybe too much because, it's still already 1 megawatt electric is a small nuclear power plant, but it's still even too large for a single person. Right. So I don't see a single use. This is very difficult to think how it can be done. But definitely I see a situation where multiple off-takers of different size and with different goal may have access to our reactor. I mentioned hospital, for instance. Hospital is one of our targets because the reactor not only produces electricity or heat, but we can generate also radioisotopes for producing radiopharmacy. And the production of radiopharmacy is very complex nowadays. Is very critical, I would say, because there are very few reactors in the world that produce radioisotope for radiopharmacy. With our model, we can bring the reactor close to an hospital. We can provide electricity and heat at the same time, generate radioisotope for application for radiopharmacy. So that's wonderful. But we can think our reactor I was in South Asia. And there are countries with several thousand of islands. Instead to build electrical grid and bring in those islands the grids, you can bring just the reactor, and this is perfect. Or in remote area for mining. Mining is also a very attractive industry for us. Usually they are in very remote area. If they don't have access directly through the source of power, they have a large problem in the organization of the supply chain of diesel generator or gas. And so the fact that we can bring directly to them a system like SOLO that allow them also to electrify their process will be wonderful. So basically, really, our reactor, the fact that our reactor is small, but it can scale up from 1 megawatt to 1 gigawatt. The fact that our reactor produces heat, electricity, and radioisotopes. The fact that we can bring the reactor everywhere and can stay everywhere because there is no risk of radiation to the population really make our product something that, as you say, I don't see in the future that the single person can use it, but a municipality of 200, 300 persons, why not? With a microgrid, why not?
Right. So if we see, when I say general population, I was referring to, so we have these societies, societies wherein, single societies wherein, there are hundreds of flats, hundreds of houses. What they do is they use
microgrid.
Diesel generators. Instead of diesel generators, you can, small reactors you can
definitely, yes.
Always use. Yes.
Definitely, yes. We are talking about the same, yes.
Right. And finally, innovation almost always outpaces regulation. As you prepare for global deployment, what is the biggest regulatory mountain you still need to climb with SOLO?
I have to say that in the US, the US NRC is doing a lot of advancement in the right direction. Recently, they issued Part 53 and in particular Part 57. And Part 57 is for the low consequence reactor. This is a term that means low power reactor with very limited amount of fissile material where if something happens, some accident happens to the reactor, there is no propagation of radiation to the population. So we definitely belong to this Part 57. This Part 57 has been already issued and will be effective starting from next year. So in US is already preparing the land for this application. Worldwide, still there is some work to do.
Okay.
I think, the fact that our reactor is very small in size, with very low capex, with a lot of benefit, the regulatory issue, which is very important because nuclear safety culture is based and put the rules on the licensing aspects, will be something that can grow up quite fast. I'm in Italy. Italy decided to abandon the nuclear energy since Chernobyl. There are now more than rumors. There are really intention to go back to nuclear. Which nuclear is still not clear, but I can see that the fact that we are small, the fact that, again, we cannot arm the population with any risk will facilitate a lot the reintroduction of the licensing framework in countries like Italy and worldwide. So, to say short, I think in the next couple of years, US still will lead the development of the regulatory framework, but very soon in other countries, this implementation of regulatory framework for micronuclear reactor will start to occur.
Right. So, Alessandro, this has been an absolutely eye-opening conversation. The intersection of breakthrough nuclear tech and shifting geopolitical realities we face today in a complex arena. And it is fascinating to see how Terra Innovatum is navigating it to build a cleaner and more resilient future. Thank you so much for taking the time today and sharing your expertise. Thank you.
Thank you very much to you, and it was very nice to be with you today.
And to our audience, thank you for tuning in. Be sure to follow ChemAnalyst and Terra Innovatum for more deep dives into the chemical, petrochemical, and global energy markets. Until next time, stay curious, stay informed. Thank you very much.
Thank you.